Welcome to the next installment of Alloy's Lunch and Learn sessions. This looks to be episode 17, so we've done quite a few of these. Today, I'm going to be covering how to configure voice VLANs on the Alloy AS series switches. So if you have any questions throughout the presentation, feel free to raise your hand and I will answer those. Just do the raise hand thing in the application, or if you want to ask something over voice, go for it. So I'll go through a brief explanation of what I'll be covering today. My name's Adam. I've been working with Alloy for almost 10 years now as a senior system engineer. In this session, I'll just give you a general overview of what a voice VLAN is, what's the advantages of using one, the benefits, disadvantages of having these in your networks. All of the Alloy managed switches support VLANs and voice VLANs. These are the AS50, AS51, and the AS30 range of Alloy switches. I do have a PDF guide that I can send you after if you like, so you don't need to take screenshots of the presentation slides for where you do the configuration steps. So I will leave my email address on the end of the last slide, so you don't need to take screen captures of what options you need to take. So just send me an email, ask for the PDF guide at the end rather than screen captures, because it's not needed. All right, so just the basics. What is a voice VLAN? It's essentially it's just a VLAN for voice. So the more technical term is it's a separate VLAN, which is a virtual local area network that is specifically allocated for the user's voice data streams. It ensures the quality of voice data by improving the transmission priority of when it is transmitted with other traffic. Meaning when other services like data, video, people downloading what they shouldn't be downloading are transmitted simultaneously, voice services can be prioritized and transmitted with a higher forwarding priority. To put simply, it's just a VLAN dedicated for voice traffic on your local network. So what's the purpose of using it? Three main reasons for using a voice VLAN. Some I find aren't as important today as they were when the technology was implemented. First, ensures that when configured correctly with all of your routing equipment, that the devices don't have to contend with other bandwidth and other traffic on your network. You can set up quality of service, guarantees IP networks with multiple VLANs are configured, are trunked, and the uplinks to the network switch. So it means you can essentially you give priority to voice traffic on your local network. So if you have a lot of things going out, you can let your voice traffic go out first. Secondly, a voice VLAN can simplify network configuration in some circumstances. It can be easier to mark QoS packets, which is quality of service, than specific various ranges of TCP and UDP ports. Similarly, TFTP and special DHCP services for VoIP phones are easier to configure when all VoIP phones are in the same subnet, which means in the same voice VLAN, so their own virtual network. Thirdly, you can also have a voice VLAN that can be used to prioritize different voice services as well. So you can have different class of service priority or DSCP markings, which is a parameter in QoS. So you could have different priorities for different types of voice on your network if you really needed to, which I dare say these days you don't, but you could. All right, so getting into the Alloy switch itself. So for voice VLANs to be enabled, firstly, on the Alloy switch, you must disable the CIST, which is the common internal spanning tree on the switch ports which you want to enable the voice VLANs on. So to do this, on the actual switch itself. So this is just a screen capture of the GUI. So this is essentially just all going to be screen captures of the GUI itself and parts there. So again, in the PDF guide, it will show you all of the steps there. So again, don't worry about the screen captures. So you log into the GUI of the switch, you log in and put in the admin credentials, go to configuration, spanning trees, so CIST ports. Under the heading CIST normal port configuration, which is what you can see here. So you disable the ports that you wish to use for the voice VLANs and you uncheck the STP enable option, and then you just select save. So the next part is after we've disabled the CIST, you can then enable voice VLANs on the switch and the individual ports you wish to enable voice VLANs on. So to do this, you go through the configuration, voice VLANs, configuration under the voice VLANs as well. And that will be the heading you can see here, which is the voice VLAN configuration. So just turn it to on, and then you set the voice VLAN ID to the number that you want to use, just to voice VLAN. So it needs to be just a VLAN that isn't in use, which is, I guess, self-explanatory, but just bear in mind, don't use another one. I'm pretty sure it'll throw up an error anyway if you try and use one that's already in use. Under port configuration, to enable port selection mode to either forced or auto-enabled discovery protocol, select both and just select apply. Okay, so the next part is you enable and set up the OUI table for your devices. So what an OUI table is, it's a vendor-based MAC address that will identify what kind of phone it is. And once configured in the switch, it will detect that a MAC address from this range and can automatically assign a voice VLAN that you decide. So what you can do here is you can specify all your type of phones. So if you're using, in this example, Grandstream, Snob, Yealink, so when the phone is plugged in and it looks for ARP, it does its ARP request, the switch will see that if its vendor MAC address matches here. I mean, it might need to be updated. I think these are some old MAC addresses, but if it matches any of those OUIs, then it will know that, hey, this is this will label it as a Yealink phone. So to automatically enable the IP handsets to the voice VLANs, so from here, to add the OUIs, you go to the configuration menu, voice VLANs and OUI. To add the entries, you click add entries and then you click a save. So from that, that will just sort of flag those MAC addresses to be in the voice VLANs. So that way, you need to put your phone's first six digits of the MAC addresses of the phones that you want to automatically hit the voice VLANs. All right, so the next part is you need to configure LLDP. And LLDP stands for Link Layer Discovery Protocol. In a nutshell, it is a discovery protocol that is used by devices to help identify themselves. LLDP allows IP phones to automatically be assigned VLANs based on their OUI, which was from the section before. Now, if the phones support LLDP, which I dare say most phones do, if they support VLANs, which again, most phones do, it will automatically be told by the switch what VLAN it's supposed to be on. So when the phone boots up, it will go to the, it'll send its ARP request. The phone will say, the switch will go, okay, your OUI is this, and then the phone will know, hey, okay, I'm supposed to be on VLAN X, whatever you've set up in the switch, and then the phone will automatically change to that VLAN without you having to configure it, assuming that your phone has LLDP enabled. Most phones, I believe, do have that enabled out of the box, or else it's a little annoying having to automatically have a config file for the phone to enable LLDP first, then for it to be able to get the right VLAN. Or else if LLDP isn't enabled on the phone, then it's not going to be able to automatically get the VLAN from the voice VLAN because it's not going to be able to pick up that LLDP request. So you need that enabled on the phone, and realistically it needs to be enabled automatically, or else it sort of defeats the purpose of having the voice VLAN automatically all set up for you. To configure LLDP, you need to go through to Configuration, LLDP menu under the LLDP port configuration. So this is just a print screen of that setting there, that page. So you change the mode, select Enable for LLDP, and select all the ports that you want it to apply to, then just select Apply. Next, the last one we need to do is need to enable LDP Med. Now, this is a protocol that is used to communicate between switch ports and endpoint devices. And as the variety of endpoints grows in an IP network, thanks to VoIP, video, and all usage scenarios that these media bring, LDP Med is an important way of the network to keep track of endpoints and treat different endpoints appropriately, depending on where the endpoint does what it is and what it does. So from the LLDP menu, you do need to do this as well. From the LLDP menu, first you need to create a policy. What this will do is it allows the setup of the voice VLAN ID that has been assigned automatically to the LLDP device. In the above example that you can see, when the device is configured to use LLDP, it will be assigned the VLAN of 50 as tagged, and the QoS will be set as voice. So that's just at the top there where you can see policies. So to configure this, you go to LLDP, you go LLDP and then LLDP Med, scroll to the policies and select Add New Policy. Enter the policy ID and the VLAN information you wish to assign, such as tagged or untagged VLAN ID. Configure the switch ports to select these policies, select Apply, and then save. So now that you've done that, you want to check if it's set up correctly. So there's two ways you can do this. You can do it through the CLI, or you can do it through the web GUI. I guess I'd like to do it through the CLI, but I'll show both screenshots of both. To verify that it's all been set up, you can do it via the CLI of the switch. To check the CLI, you can connect via Telnet SSH console. And when you're logged in, you simply type in show MAC and then the address table. And from here that you can see that there is the, what have we got here? You can see that the yelling phones have been set up on VLAN 50 there via LLDP. And on this one here, then that's just essentially the same thing you saw, but from the web interface. And that is from the menu, you just go to monitor and then MAC table. So I guess the main thing is it worth doing now? Is doing voice VLANing and setting your whole network up for VLANs and voice and QoS and DSCP marking, is it worth it in today's day and age? Personally, I believe voice VLANs aren't as important as they used to be, let's say 10 years ago. Saying that, there are advantages of having them. They do add layers of security, that phones are on different VLANs than other devices such as PCs and other things that you may not want to be conflicting. You don't want someone to be on the same network as your phones. Maybe you've got confidential conversations that you don't want someone snooping in on, and you might not be using secure RTP or those kind of things. You might be in a highly sensitive environment. You are in a very large organization, a corporate building, a corporate, and they've got, I'm talking like a very large, big, 200 plus computers, phones, where you might actually have congestion on the local network, and you might not have large, 1 gig or 10 gig up hot, 10 gig links between switches, and they may have local file servers where they're sending things daily, marketing stuff, where those links might get congested. That's where you will find where local QoS will help your phone calls. But for everything else, I mean, this was good back in the day when we used to have ADSL connections and bandwidth constraints. I know before the days of fiber and people were all on ADSL connections, bandwidth constraints, G729 was a big thing for, phone calls, for limiting bandwidth. Everyone had one ADSL connection, and then you had to make sure that the phones were on G729 to reduce bandwidth, and people used the one connection for phones and browsing. And if you didn't have QoS set up and voice VLANs, whenever anyone decided to download anything or upload a file, everyone's voice would go down the drain. So back in those days, this was extremely important to make sure that phone calls weren't affected. But now when everyone's got, I don't know, 50, 100, 200, 1 gig pipes, a phone call that takes 128K is nothing. So it's not as important as it used to be. But I mean, it doesn't hurt. There's no harm in doing it. It's still useful. But it does take some configuring. You need to also configure your phone. If you've got a local phone system, you need to configure the voice VLANs and the VLANs on that. You need to do routing on your routers to make sure they can route between the different voice VLANs and the different networks if you need it to. So there is more work to it. And if it's a small organization, you might not need it. Like it might just be a bit of overkill to have all these set up. It's just sometimes, today you don't really need to have that sort of configuration for bandwidth constraints if that's the only reason you're doing it. And the other thing is now, with COVID, like how many people are working remotely? You've got everyone working from home, so you can't really even have voice VLANs for remote workers because they're all working from home. And so it's not really going to be a thing at all. So I think the only real use case personally is in a large corporate environment that have lots of workers there, or sensitive data, banks and big companies that have those really large buildings and large amounts of data throughput throughout their buildings, throughout their networks, that will need that send 1 gig, 10 gig throughput of data through their switches and all those sort of things that can fill up. But it's I guess it depends on the scenario, honestly. So I guess honestly that's about it, really. There's my email address there. If you want a copy of the PDF guide, just copy my email address there, send me an email, and I'll send you through the PDF guide, which goes through step by step on how to create those voice VLANs on our switches. And if you go through the guide and have any issues, just send me an email and I can help you through it. But if you have any questions, just give me a buzz now, and yeah, let me know.